Welcome to Ask and Learn.
In this problem, we have, it's kind of interesting, we have a rod here that's resting in a bowl, and we want to figure out the angle of inclination of the rod from the horizontal. Actually, it's from a mechanics point of view, it's not that difficult. It's really just more the geometry that's hard to get a handle on. So one of the things that you first need to realize and convince yourself of is that this angle here, so at some point we need to know the angle between where the center of the bowl is and the end of the rod, that angle is the same as this angle, the angle between the rod and the horizontal. You can kind of convince yourself that, geometry will prove that if you do it right. But you can convince yourself of that by looking at the force, the forces, or this force here, and seeing that it must act through that point. Again, you can try to convince yourself that that's true. I don't want to go through the whole proof that this equals this, but it does. I guess partly what you can do, I guess the best way to do it, I just thought of a good way of showing it easily, is this angle must be theta because this angle is, right? So then this forms a triangle, and because of symmetry, then this angle has to be this angle, which is this angle. So that's how you do that. And so I have first force here is P, and has a magnitude of P, and the direction, again, you can convince yourself that this angle here is 2 theta. Well, I mean, it's along this axis, so this is 1 theta and 2 theta. And I'm going to use this as my origin. And then the second force is up here at V, and it is perpendicular to the rod, has a magnitude of V and is perpendicular to the rod, and at a distance D from the origin, but at the position vector is inclined. F3 is the weight, and R3 is just half of the length of the rod, which I guess I've kind of drawn that poorly, but it should be in the middle of the rod. Suppose I could take some of the rod off. And then the other thing that I guess is a little bit hard to, well, not too hard to determine is what this length D is. And just using these triangles here, you can see that it's 2r cosine theta. And after that, we have all the information we need to just start summing forces and moments. And we'll get 3 equations for 3 unknowns. One of those unknowns will be theta. The other 2 will be P and V. I haven't given explicitly what those are here because we aren't given L or R. So I mean, the expressions for these guys are pretty lengthy and not that informative. But you can figure out what cosine. You can eliminate P and V and get an equation just for cosine of theta, and well, kind of for cosine. Get a quadratic equation for cosine of theta, and then use the quadratic formula to solve for cosine of theta, and you give this expression here. And they a couple of checks maybe to see is that, well, if L equals R, so that the radius of the bowl is the same as the length of the rod. So the rod's pretty short. The one answer will be that theta equals 39.4 degrees. Obviously, because there's a quadratic equation for cosine of theta, you get multiple answers. Obviously, you could have it over here. I mean, you could have it resting across the bowl. There's lots of answers you can get, but this is the one that is kind of illustrated in the book. And then you can see that if L is a whole lot less than R, then the angle goes to pi over 2. And again, as you can see, and then I made a plot here, and this is a plot of R over L, and this is theta in degrees. And so you can see that if L gets too big, so that the rod is too long, you don't have a solution, because at some point the rod is going to fall out of the bowl. Or basically you would get this solution, the solution that I plotted here, this one would break down, and you would wind up with a solution that says that this thing has to be pulling down on the rod, which it can't do, and so that's not really a valid solution. So you have no solution where there's 2 points in contact with the rod. And so it's actually this when R is 1/4 of L, when you start to have real solutions. And you can see that at that point the solution is 0. The angle is 0. So at that point you have this solution. In fact, for L equals less than 2R, you always have this solution, but then you also have these other solutions. And so what you can see is that this thing basically quickly goes up and then asymptotes to 45 degrees.